you see that x could be you need to know the distribution. X could be 1 or -1, right? You can win $1, you can lose $1, and the probability of winning is 18 over 38. Okay, there are 38 options, 36 numbers, 0 and 00, so 38 options, and you can win with the probability 18 over 38, and you lose with probability 20 over 38. Okay, so the average value of x is the mean is this EX, which is 1 times 18 over 38 plus -1 times 20 over 38, and you get -2 over 38, and you get -1 over 19. Do you understand? Any questions so far? Is there any questions? Well, X is your gain, right? So if you win $1, you can win $1 or you can lose $1. All right. Is that okay? May I move on? May I move on? Yes, one time. Yeah, you played the game only one time. That's true. Okay, suppose that y is your gain after 10 games. If you play the games 10 times, all right, what is your net gain? Do you know that? If you play 10 times the game 10 times, what is your net gain? If you play the games 10 times, so it should be so y is simply 10 times x, right? And then you get the mean value of y, which is 10, the mean of 10x, and that is 10 times the mean of x. All right, so you get 10 times -1 over 19. All right. Okay. So it's just like the more you play, the more you lose. Okay. Is there any questions so far? It's okay, right? Okay. All right, let's move on to the next example. why 10 times is 10 times x, not x to the 10? Well, if we are talking about the next gain, then let's say suppose that you have x1. Suppose that x1 is your gain the first time, right? x2 is your gain the second time. Am I right? x3 is your gain the third time, and so on. So and then you get x10. There are 10 games. Then you have 10. You have 10 gains in those 10 trials. Understand? Then you come up with a sum. This, right? This will give you the gain. Correct? Do you understand what I'm saying? Suppose that x1 is what you get for the first game, for the first trial. x2 is what you get for the second trial. x3 is what you get for the third trial, and so on. Do you understand what I'm saying? Okay. Then you come up with the mean of y equals the mean of x1 plus x10. Well, if you want to explain it clearly, this is the way we do it. Then you come up with the mean of x1 plus the mean of x10. All right. And then you come up with what is the mean of x1? The mean of x1, the mean of x1 should be the same as the mean of x. So you get it is the same as the mean of x because they follow the same distribution. So you get this one, and you come up with 10 times the mean of x, right? And that's why you get 10 times minus 1 over 19. Okay, that is a very good question. In fact, yeah. When I say equals 10x, well, we should put a question mark here because it is not really correct. We should explain it this way. Let's say x1 plus up to x10 because you have 10 different games, right? So it should be something like this. Okay. Thanks for your question. Okay. Now, suppose that we have this model where the capital X is the number, the amount of memory in a gigabyte for the amount of memory in a flash drive. Okay. Then can you find the average amount of memory? What is the average amount of memory in that flash drive? You need to find the mean of x, and that is simply 1 times 0.05 plus 2 times 0.1 plus 4 times 0.35 plus 8 times 0.4 plus 16 times 0.1. Do you understand? Is it clear? Is it okay, you guys? Okay. All right. So that is the case when you get a discrete random variable. What if you have a continuous random variable? What if you have a continuous random variable? if you have a continuous random variable, then oops, I mean this one. Then you want to find the mean of x. Can you do that? In this case, the mean of x is simply the integral from minus infinity to infinity. U times f of u du. And that would be the integral from 0 to 1, right? Because outside the interval, the function is 0. Then you get u times 2u du. And that is 2 excuse me, 2 times u to the third over 3 from 0 to 1, and you get 2/3. Understand? Okay. Suppose that x is the amount of time a book on 2-hour reserve is actually checked out, and suppose the density, the cumulative density function is this one. Can you find the average amount of time that the book is actually checked out? Can you do that? Do you know how to get the answer? Okay, so in order to solve the problem, you need to find the letter f first, right? And from here, I can conclude that the letter f is equal to 0 if x is negative, and 0 if x is more than 2, and then you get x over 2 if x is between 0 and 2. Then the mean of x is simply the integral from 0 to 2. I don't need to integrate from minus infinity to 0 or from 2 to infinity, because the function, the density function, is always 0 in those intervals. And for this integral, we have the integrand x times the function f of x, which is x over 2 dx. And then you get x squared, so you get x to the third over 6 from 0 to 2, right? And it gets 8 over 6, which is 4 over 3. Is that clear? Okay. All right. Now I want to find the second moment. What we get is the mean of x, and the mean of x is simply the integral of the x times the density function, right? So you can think of x as the distance and f of x as the weight or the density. So you come up with the moment, right? This gives you the moment. Am I right? And you call it the first moment because the power here is 1. You can also find, you may also want to find the second moment, which is this, all right, and come up with the square. So how can you get that? Let's go back to the model in which you get you flip two constants, then you get 0, 1, 2 with probability. Let me go back to the sample. Which sample do we have here? So let's say 0, 1, 2, and we get 1/4, and you get 1/2, and you get 1/4. Then the mean of x in this case is 0 times 1/4 plus 1 times 1/2 plus 2 times 1/4. So if you want to find the mean of x squared, because x is a random variable, x squared is also a random variable. So you get 0 squared, 1 squared, 2 squared. Okay. Then the mean of x squared, is simply the mean, this one, right? You get 0 squared, and you get 1 squared, you get 2 squared. That's it. And then the answer should be what's that? You get 1 and a half, right? 3/2. You get 3/2. Therefore, we have the following formula for the second moment: the expected value of the random variable x squared. All right. In general, for a function g of u, then you can also find the mean value of g of x. Okay. Is it okay for you? Is it all right? Okay. All right, let's consider the following example. So you see that you replaced instead of u, you have g of u. Instead of u times f of u, you get gu times f of u. That's it. Okay. Now suppose that x is the current measured in milliampere, and the density function is 0.05 for any x between 0 and 20. What is the average value of power when the resistance is 100 ohms. Okay. Why x squared over 4 becomes x over 2? Well, you need to find the capital. This is the cumulative distribution function, okay? And in order to find what happens here, in order to find the mean value, you need to in order to find the mean value, you need to use the density function. So it should be letter f, not the capital F, right? So in this example, you have the capital F, and you need to find letter f, which is the derivative of the capital F. That's why you need, when you differentiate the functions, you get this one. Is it okay? The second moment, well, do you remember the moment in physics? Do you remember that? Do you remember the concept of moments in physics? The moment is equal to the force times the distance, correct? Okay. And using that idea, you can come up with the first moment, and you can come up with the second moment, right? Is it okay? Well, do you remember what you study in physics? The moment is equal to the distance times the force, right? Okay. So at one of your friends mentioned equals F times D. So in this case, if you have a look at the let's say you have the origin here, and this is you have a point, right? And the distance is going to be d, and this is f, right? And you get the moment should be f times d, right? Something like that. Okay. Now you get the sum of k times f of k. Okay. Do you understand? You get k times f of k. F of k is simply the Fox here, right? And k is simply the distance. You can think about it that way. Okay, and this gives you the mean of x. So the mean of x is the first moment. If you want to find the second moment, you get the sum k squared f of k, right? So it's just like you can think of the Fox times the square of the distance, and that is called the second moment. Okay, so it's just like you want to find if x is a random variable, and then x squared is also a random variable, right? You cannot predict the value of x squared, and you want to find the value, the mean value of x squared, then it is simply the sum of k squared times f of k. Do you understand that? Is it okay, everyone? All clear. Okay. And that is for the second moment, and for sure you can consider the nth moment. Should be the mean of x to the n, right? And you can come up with the sum k to the n f of k. That is for several points. If you have consider the case when you have a disk here, right? Or let's say you have a, you get like, a part of of a line like that, and you have a string like that, and this is the origin, and you want to find the moment of this one, all right? Then you come up with, instead of using the sum, you can get the integral. So that would be the integral from minus infinity to infinity of a function u times f of u du. And it is x to the n here, then you should have u to the n. All right. Now, if you want to find the mean value of g of u, g of x, then you need to replace u to the n by that function. Okay. So if you get g of x here, then you have g of u right here. It is g of x, and that should be g of u. Okay. Now we have a function. Now we have a problem. Suppose that actually is the current measured in milliampere, and you get the density function f of x equals 0.05 for any x between 0 and 20. What is the expected value of power when the resistance is 100? Do you understand? Can you solve the problem? Do you know how to solve the problem in this case? You want to find, you see that suppose that I is the current measured in ampere. Okay, suppose that I is the current measured in ampere, then I equals 10 minus to the third times x. Okay, and the power is simply r times I squared. And the effective value of power, the average power, is the mean value of r times I squared. Is it okay? What is r times I squared? R times I squared is 10. 10 is 100, right? Times I squared, which is 10 minus 3 times x squared. And then you get 10 minus 4 x squared. So you come up with the mean value of 10 minus 4 times x squared. And you get 10 minus 4, and the integral from 0 to 20. And then you get x squared times the density function, right? F of x dx. And f of x is simply 0.05, okay? And then you can simply use the calculators to compute this integral to get the answer. Okay, is that all clear to you? Okay, everyone? Okay. Oh, this is another example for you. Do you know how to get that? May I skip it? Can I skip it? Is it okay? Okay, sure. What is the cost? The cost is x to the third, and you want to find the expected cost. That would be the mean value of the cost, right? So you get the mean value of x to the third, and it is the integral from minus infinity to infinity, x to the third, f of x dx. And you get the integral from 0 to 1, x to the third times the function f, which is 1, dx. And you get x to the fourth over 4 from 0 to 1, and you get 1/4. Is it okay? Is it all right? Is it okay, you guys?
Yes.
Okay, good.
Thầy ơi cho em hỏi thêm được không ạ?
Yes, of course.
Dạ em biết được cái công thức, em tự dùng công thức em tự tính được rồi, mà em không hiểu cái con số 1/4 cái kết quả của mình nó là trong cái bài này là nó có ý nghĩa gì vậy thầy? Cái expected cost kiểu như nó có ý nghĩa gì trong cái bài này vậy thầy?
It is the average cost. It is the average cost. You think about it this way. Suppose that, think about it this way. Let's say we knew that the time, the cost is actually the third. So and the time in and x is the time in hour it takes to locate and repair an electrical breakdown. Is it okay? So let's say suppose that, let's say, for example, if you need 1 hour to prepare it, then you have to pay, let's say, then you have to pay, let's say, 1 million. All right. Okay, or let's say, let me see, $1,000. All right. Do you understand? Or let's say I would say the $1,000, right? And then if you get if you need two hours to fix it, then the cost would be $4,000. Okay. Do you understand what I'm saying?
Kind of.
Okay, just like the unit here, you come up with the unit, or let's say this is what you have to pay, 8. If you need 2 hours, then you need to pay 8. All right, and then if you need 3 hours to fix it, then the more hours you need to fix it, then you need to pay more money. Understand what I'm saying?
Cái 1/4 cái kết quả mình là cái giá trị trung bình cho bất kỳ cái thời gian nào. Yeah.
For the cost, that's true.
Yeah.
Okay, so so if you so this is what you can see. This is the model you get, right? Now suppose that you you know, in the company there are many there are many breakdown like this one, and then the first one, in the first one you can see that this is, in this case, U is between 0 and 1. So let's say if you get in the first for the first breakdown you get you need 1 hour. In the second one you need let's say 0.5, and then in the third one you get 0.2, something like that. Understand? And then you come up with the corresponding cost. What are they? 1, 0.5 to the third, 0.2 to the third. Correct? Understand? Do you understand what I'm saying?
Yeah.
And then 0.1, for example, and then you get 0.1 to the third, and then you get 0.1 means you have what is that? 6 minutes, right? And then you get 0.1 to the third, and so on. All right, and then you come up with the average value, right? You come up with the average value. You find the average value of all these numbers. All right. Okay.
Okay.
That one will be very close to 1/4. Do you understand?
Yeah.
Okay. All right. So 1/4 is the average cost. Okay. Do you understand, you guys? All of you? Do you understand the concept?
Vì sao họ lại không dùng cái từ average để dùng cái chữ A để cho tên hàm mà lại dùng cái từ expected vậy?
Okay. Well, as I said, there are lots of names that you can use for that. You can call them the expectation, the expected value, the mean value, and the average value. You can't call them the average value, obviously. And why do we call it the expected value? Well, in fact, it is due to the law of large numbers that we are going to learn later. But you can think about it this way. Suppose that there are, x1 is your observation following the same distribution. You get x2, x3. This is the first cost, the second cost, the cost of the second event, the cost of the third event, and so on. And then you come up with the xn. Then you can come up with the average value of all of them, right? And I consider this one, and I know if it's by the average value. Okay, then we can prove that this one will be will be very close to the E of X, the mean value of X. All right. And the mean value of X is what you expect to observe. Okay. So this is what you actually, this is the value you expect to observe, understand? And that's why you call it the expected value. The X bar here is the average value, right? This is what you expect to observe. And then you can see that, and then it is in fact the average value. You can call it, that's why you can call it the average value as well. In that sense, make sense? So there are many names that you can use for EX. You can call it the average value, the mean value, the mean, or simply, or the expected value, the expectation. They are all the same. They are the same thing. Okay. Is it okay now?
Yeah, it's okay.
Okay. All right. Now I want to talk about the median. That is the mean value. I believe that you already understand that. So you get 1, 2, 3, 5, 10. Then you can find the average value, which is 1 plus 2 plus 3 plus 5 plus 10 divided by 5, right? That would be the H bar. And then if you change the numbers a little bit, then the value of H bar will be different. Okay. Is there any way to get a number that will not be affected by this number? Like if you have a typo, then this typo will affect the average value a lot. Is there any other ways? Is there any other ways to define the average value, such that even if you have a typo right here, it doesn't really matter? Then do we have that? Do you have another way to do that? Then instead of finding the average value, I will find the value at the average location, the middle location. Understand? So I arranged all the numbers in increasing order like this, and then I determine the one at the middle. In this case, it is 3. Okay, so this number 3 is called the median. Okay, I call it the median of X. Okay, now what if there are 2 values at the middle, like 1, 2, 3, 5. Then we have 2 numbers here. Then the median is simply the average value of the 2 numbers, 2 and 3, and you get 2 plus 3 over 2, and you get 2.5. Is it clear? Do you understand? Is it okay? All right. All right. This is the way you define the median for observations. How can we define, for example, how can we define the median for a population? Suppose that you have suppose that X is continuous random variable. Then you come up with the following density function. Then the median is the point that divides the whole distribution into 2 equal parts, right? It divided the whole distribution into 2 equal parts. So you get 0.5 for this and 0.5 for this one. Is it clear? For example, suppose that we get the following density function. So you get this one, and then I guess, let's say I get this. All right. Suppose that this is the function f of u. All right. How can we find the median? The median is the point the median is the point that divide the whole distribution into 2 equal parts. So you get 0.5 right over here, 0.5 over here, right? Understand? And then I can consider this area. You see that we have two triangles. We have two triangles. That's the blue one and the yellow one, right? Can you see that? The blue one and the yellow one, right? And you see that the ratio of the two areas, S1 over S2, is simply 0.5 over 1. The area of the yellow one is 1, so you get the ratio here. This is the median, right? And the ratio of the two areas of the two areas is simply the square of this distance divided by that distance, right? So you get MD. Suppose that this point is 2, then you get MD over 2 all square. Do you understand what I'm saying? Is it okay, everyone? Does that make sense to you? Is it clear, you guys? Is it clear? Hello? Again? Okay, what is the area of this one? The area of this one is 0.5, right? Do you understand that? Do you understand? The area of this one is 1, correct? So if you divide the so you get S1 for this and S2 for the bigger one, then S1 over S2 is 0.5 over 1, right? And the area, the ratio of the two areas is the square of the two sides. The side, this side is MD. The other one, the longer one is 2. So you get MD over 2 square. Do you get it? Okay. So you come up with this equation. So MD square equal MD square over 4 is 1/2. That's why MD is the square root of 2. So the square root of 2 is the median of the distribution. Do you understand? Is it okay? May I move on? Is it all right? All right, now we can go back to this problem, the problem I gave you over here with this function, capital F and little f. How can we find the median if you have the little f and the capital F? Well, the median is simply the point. The median is simply the point such that the area from the leftmost to that point median is 1/2, right? So I want to find the point such that the integral from -infinity to that point fu du is 1/2, and it is the point such that the capital F of MD equals 1/2. Therefore, in order to find MD, I need to solve for x, such that f of x is 1/2. Correct? This is what I need to do if I have the capital F. So I need to go back, then I can go back to this example. And you see that f of x is 1/2 means that x squared over 2 over 4 is 1/2. And then I can conclude that x is the square root of 2. And then I can conclude that the median is the square root of 2. Do you understand? Do you get it? All right. So for continuous distribution, we need to solve for x such that f of x is 1/2. Okay, this is what you need to do. All right. Okay. If x is a discrete random variable, then the median is the point such that the probability that x is less than or equals to MD is greater than or equals to 1/2, and the probability that x is greater than or equals to the median is also greater than or equals to 1/2. So if you can find that point, then that point is called the median of the random variable. Do you understand? Let's consider the following example. Let's consider this example, and you will see the point. I want to go back to this. Okay, let's consider this one. Okay, what do you think? Then I can find the probability that x is less than or equals to little x. What do you get? It is 0.05, 0.15, 0.45, right? Wait a second. I think it should be 0.5, 0.7, wait a minute, 0.9, and then 1. Okay? Do you understand? Is it okay? It means that the probability that x is less than or equals to 4 is 0.5. Okay? So it is less than or it is greater than or equals to 0.5, right? 1/2, right? And then what is the probability that x is greater than or equal to 4? What is that? It is 1 minus the probability that x is less than or equal to 3 to 2, and you get 1 minus 0.15, and that is, what is that? 0.85 greater than or equal to 0.5 as well. So the median of x is 4. Is that clear? Do you understand? Okay. So if you have if you have a distribution, if you have something like this one, then you need to find the points such that let's see. So you say that 4 is the median if this, the probability that x is less than or equal to 4, the sum of all the 3 numbers is greater than or equals to 0.5, and the sum of these 3 numbers is greater than or equals to 0.5 as well. Is it okay? Then this point is called the median of the distribution, or let's say the median of the random variable x. Okay, that makes sense? Good. And based on that, you can also there should be some other similar definitions, but I will skip that part. Now I want to move to the next things. I want to move to the variance of the random variable x. But so far, what we have learned is about the chance, right? The distribution. To learn the chance, in order to get the chance to get, let me see, I would say the distribution, right? Then you want to talk about the values, and then the chance, and then you get the P and F together with the P, D, F, and then you get the C, D, F, right? And then you want to get some characteristic. For now, we want to learn how to describe the center of the data set, in which you use the mean value, then the median. All right. Now I want to talk about the variance. What is the variance of x? What is the variance of x? And why do we need to talk about that? Let's have a look at the following graph. Suppose that there are 2 classes. In the first class, the relative the scores are 5, 6, 7, 8 with the same relative frequencies, to 25%. In the second class, the scores are 3, 4, 5, 6, 7, 8, 9, 10 with the same relative frequencies, 12.5%. You see that in these two classes, the average scores are the same, 6.5, right? So you see that the mean values are the same. However, the 2 distributions are different. It means that the mean value does not provide enough information about the distribution. Okay, well, it is a very important characteristic, but it is not everything you need, right? It is not enough. So you want to get some other thing that can give you some more idea about the distribution, and that should be the variation. You want to know how the scores vary around the mean value, right? So I want to learn about the variation of the scores. Okay. And how can we define the variations of the variations of the mean value around of the observations around the mean value? Then I'm going to share this file with you so that you can see the point. All right, can you see it? Can you see the fire? Now suppose that there are 4 observations, 1, 2, 5, 8, and then you can find the mean value of those 4 values, 1 plus 2 plus 5 plus 8 divided by 4, and you get the mean value, the average value with 4, and then you get 4 numbers, right? 1, 2, 5, 8 together with the average value, and then you can find the derivations. 1 minus 4, which is minus 3, 2 minus 4, 5 minus 4, 8 minus 4. Okay, if all those derivations are close to 0, then we believe that we think that all the observations are close to the mean value. It means that the variation is small. If all these numbers are far from 0, then we believe that the observations are far from the mean value, and the variation is big. Okay, then I compute. It is very natural to compute the average value of all of the squares of all these deviations. So I compute the sums of squares, and I divide the sum of square by the number of observations. Or later on, we can divide that by the degree of freedom. Okay, and this value is called the sample variance. All right, so this gives you some idea about the variance, and the variance is simply the mean value of x minus mu squared, where mu is the average value, the mean value of x. Okay. If x is a discrete random variable, then the mean of x minus mu squared is the sum of u minus mu squared f of u, right? And if x is the a continuous random variable, then the variance becomes the integral from minus infinity to infinity u minus mu squared f of u. Is there any questions so far? Is that all clear? That makes sense to you? Is it okay? All right. Well, in fact, at the beginning it is n. I agree. At the beginning it should be n. However, when after you define the variance, we come up with the concept of bias, and it seems that it can be proved that if you use n, then you come up with bias estimator of the variance. That's why you replace n by n minus 1, and by doing this, you can get a bias estimator of the random of the variance of x. Okay, so if let's say, think about it this way: if this this is the definition, right, of the variance, and this is the variance of the whole population, and this formula is the formula for the variance of a sample. And every time, so you have many samples. You have a single population, but you have many samples, and for each sample you have a single you have a different sample variance, right? And if you use n, then the average value of the approximations will be less than the actual variance. Understand? So if you use n instead of n minus 1, then the average value then it will be a better. So it will give you a better approximation for the variance. That's why we use n minus 1 instead of n. And later you will see that it is better to divide the sum by the degree of freedom instead of the number of observations. Do you understand? All right. Okay. All right. So and here you have the formula for the variance, right? Okay. Sometimes I use V, sometimes I use VAR. They are all the same. And if x is if the unit of x is dollar, then the unit of the mean value is also dollar, right? But the unit of the variance is dollar square. Therefore, and if you want to get something with the same unit, then you need to apply the square root of the variance. Then you come up with the concept of the standard deviation. Then the standard deviation of x is simply the square root of the variance of x. Do you understand that? Okay. So as I said, the square root of the variance of x is simply the standard deviation of x. Okay. So I'm going to give you one more example. This will be the last example I want to explain. I want to discuss today. Okay, suppose that x is a random variable taking the value 0, 1, 2, 3, 4 with the Boltzmann function like this, and you want to find and then you come up with this table. Then you multiply the first and the second columns to get the third column, right? And then you get 0.4. What is 0.4? 0.4 is the sum of x f of x. Then it should be the mean value of x, the average value. And then you can compute the deviations square, right? X minus 0.4 square. And you multiply the fourth column by the second column to get the fifth column, okay? And then you find the sum of all the numbers here to get 0.36. That would be the sum of x minus 0.4 square f of x. And that is the variance of x, okay? Do you understand? Is that clear? Do you understand that? Okay. All right. I think that's enough for today. Let's stop here and see you next time. Thank you very much and goodbye. Okay.